right, well, good afternoon, everyone. My name is Ty Martin, and I'm a postdoctoral fellow in the Chemical and Biological Engineering Department, and I'm advised by Professor Heather Canavan. And first, I'd like to start off with a question. So what if every time you enter or leave a building, you have to wait 15 extra minutes for someone to unlock and open every single door that you might need to get through? So if, for instance, like me, you have an office on the second floor of the UNM Centennial Engineering Center, you would be waiting over 2 hours total for doors to open, assuming you only enter and leave one time. So in other words, you wouldn't be leaving for a quick break to walk around the duck pond or go get your cup of coffee at Satellite. So for people that use wheelchairs like me, sometimes something as simple as getting to an office each day can be a major barrier to your success at UNM or wherever you have an office. So my research is literally and figuratively focused on developing technologies to open doors for people who have unique daily living needs. And these needs might be short or long-term due to health challenges from surgery recovery to disease. So today I'll be showcasing an adaptable modular system and apparatus for personal wheelchair accessories. And we call this technology the Sidekick. So if we look on a national scale, actually 1 in 5 people deals with a disability in the US currently. And if we look at that on a worldwide level, there are more than 1 billion people who have a need for assistive disability devices. Many of these daily living tasks that people go through involve physical disabilities, and these are impacted by equipment built to be ADA compliant, but not necessarily ADA friendly. So if you look at this schematic here, this is just an example showing that, even if you have an assistive piece of equipment like a wheelchair, you may not be able to access simple things like an ATM machine. Okay, so let's take a look too at the impact of non-adaptive tools for people with disabilities in the employment sector. So recently, the US Department of Labor actually reported a nearly 50% difference in total labor force between able-bodied individuals and those with a disability. So again, even with the ADA passing over 30 years ago, there continues to be this large gap. And so the idea is that more adaptive equipment and tools would allow these people to better enter the workforce and be able to be full members of society. And of those with disabilities that do have employment, the earnings are currently much less than people without disabilities. So with this information in mind, let's take a moment to consider the need and market potential of the technology that I'm looking at here. So assistive technology that's currently available on a broad scale really suffers from what we call the one-size-fits-all problem. So in other words, assistive devices such as an automatic door on a building continues to be a barrier. For example, it's not all wheelchairs are the same height, and users of wheelchairs have different abilities. So some may have full upper body strength and others may not. And so if a button is installed too high or too low to open a door, again, it's a problem for access. And one interesting experience I've actually had working with Professor Canavan at UNM is we looked at finding a solution to entering doors into the Centennial Engineering Center. And what's interesting is many of the automatic doors that were already installed were fitted with this antenna that could be opened with a remote control. But when they were installed initially, those antennae were not activated. And so this is one really simple example even of us going through the building, activating these antennae, and we had a remote control that opened the doors. And from that point on, I could enter 2 to 3 more doors than I could before. So it's all about finding ways to make things as accessible as possible. And so again, independence is often overlooked when these technologies are installed. And through our group at UNM, we're trying to improve user experience through thoughtful design of different technologies. And at this point too, I want to point out that the wheelchair market itself is actually projected to hit $6 billion by 2022. So there really is a market that's untapped for more adaptive pieces of technology. So just as a broad scope example of our approach, so we're looking to find innovative solutions that help people with adaptive needs to pinpoint barriers. So for example, this fence. So typically what's done today is what we call a first degree change. So that would be something like putting a simple ramp here for the person in the wheelchair to access this view. But what we're really wanting to do with our group is to go through a second degree change where we remove the barrier entirely. And so that would really improve the autonomy and independence of the individual. So all of this brings me to our innovation of an adaptive wheelchair framework for assisting with daily living needs of wheelchair users. And this is to assist them actually with tasks from the hips up. So if you think about a wheelchair, it's designed for transport and needs below the waist, but there really hasn't been a concerted effort to develop technologies that help from the waist up. So things like opening doors, holding laptops and typing on them, other simple tasks like eating and drinking. And the device that we're developing is modular, so it's tailored to the specific person's needs. And we like to call the people in wheelchairs the adapters. So we really want to be able to give them self-directed mobility on a daily basis so they can reach their full potential. And the innovation of our device is the way that we're combining our tools that doesn't inhibit the wheelchair functionality. And so we're designing something that the user has control over as far as the number of features that they want to include or the amount of automatic or analog components they want to include. And I'll get into that a little bit more later when I show you the current version of our prototype. We look at some of the applications of Sidekick. So really, we went through the I-Core site program, and our customer discovery interviews so far have shown us that the wheelchair is more than just a chair. It's actually an ecosystem for the individual. And so we want to incorporate things like umbrellas, mirrors, cup holders in a way that's distinct from these shown here and are more user-friendly and easier to access for the individual. And so here's an example of what we're looking at. So items like this umbrella and cup holder need to be designed to adapt to the user's environment. And to provide full independence, we're looking to create tools for recreation, nutrition, charging electronics such as laptops, and we're trying to combine that in a way that doesn't interfere with the transportation. There's several different state-of-the-art technologies that are out there right now, and we're looking to try to incorporate these into the next version of Sidekick. And these include things like this is an eating robot arm. It's a little bit limited because it actually has to be sitting on a table or desktop. There's also this exoskeleton suit, and that's a more extreme version of technology that's available for helping people to stand and actually move. But again, we're looking to incorporate robotics as far as something more like this functionality where it helps with eating or drinking. And also there's one out there currently that has these fingers here. So it does have a little more control than something like this. So you can actually reach out and grab different things. There are several issues with some of the current technology. Affordability is the biggest one. So insurance actually doesn't cover many of these technologies because they're not considered as essential for daily living. And so affordability is a major issue. Time is another problem. So a lot of these technologies, by the time they're refined and adapted enough for the users to actually use, it's quite a few years. Something else that they don't usually take into account is human factors. So this is basically looking at ergonomics and user experience of the devices. And so our goal is to make it as user-friendly as possible. And part of my research too is to determine which of these features to build from scratch to attach to our device, or which ones to potentially license from other companies. So far results, we've actually filed a utility patent on the device through UNM Rainforest Innovations, and we've designed a website for outreach and bringing together our adaptive research with other groups that are out there. So here's just a snapshot of one part of our website showing the different features. Um, and another thing that's come out of this research is we've developed a pathway for other adaptive technologies. And so we first pinpoint the unmet activity of daily living need. And then through an I-Core-like process where you go through and have customer discovery with not just users and caregivers, but specialists and medical professionals, occupational therapists, we can go through and identify a solution that's adaptive to each type of user group, and then proceed with rapid prototyping, and then optimizing, and then deploying for testing to early adopters. So currently we're building and testing the version 1 core prototype of the Sidekick, and we're calling this the core model. And the core consists of a carapace or a shell. And here you can see it positioned on one of the motorized wheelchairs that we're working on right now. And this shell actually is a housing for external and internal components. And so some of the major components that we're attaching to the carapace, these include things like RFID sensors, and that would be helpful for opening doors remotely. The arm extensions that I mentioned earlier. And if we take a look at, there's an image here showing this is the manual version of one of our arms, and we're prototyping on a robotic version right now. In the future, we want to look at things like solar panels to help power some of the electronics housed in the carapace, a framework that's hardened and helps to stabilize any type of circuits or CPUs that are embedded inside here. And then there's also features like a camera LED system to see what's behind you when you're driving. So all of these features will help students, professors, employees, and others with control over their lives if they have unique adaptive needs. And the next version of the prototype, we're going to incorporate additional feedback that we get from early adopters. So in the next 6 months, we have a projected timeline that covers both technical and commercial tracks. So currently we're establishing our online presence and working again on the core model. And we're also looking at an app to control various parts of the Sidekick that's either voice controlled or joystick controlled. And we're also looking at completing branding, forming a board of advisors, and finalizing our IP protection. The next phase is to actually research more in depth into human factors engineering and complete the first version of our app. And for testing, we're looking at getting IRB approval. And one of the interesting things we're trying to do is to develop these virtual hackathon sessions. And that would allow people from across the country to come together and work on these devices. And then we're looking to, we actually were approved to join the I-Core National Teams program, and we'll be starting that at the end of March. And then finally, we're going to be looking at completing materials analysis and user testing, and then optimizing the core model. And on the commercial side, looking to submit an SBIR proposal and promote the Sidekick nationwide. So now I'll just quickly introduce you to the rest of the Sidekick team. So we have graduate students like Ben Matheson and Veronica Mitchell. They're working on human factors design and operations and management of the Sidekick project. Ankit is actually an undergraduate student working in computer engineering, and he's working with me on the app and robotics phase. Jonathan Yarmy has been working on the construction of the carapace, and been advised and mentored by both Susan Cornelius and Heather Canavan on the project. And I'd also like to acknowledge my postdoc funding through the ASERT program and the various UNM I-Core and National I-Core programs that I'm involved with, as well as a few of the rainforest pitch competitions, which we've been fortunate enough to win. So I'd like to thank you all for joining me and invite you to visit the webpage and our social media profiles, and I'd be happy to answer any questions.
Great, thank you, Ty, that was great. Do we have any questions? Okay, I got one question here. What do you believe is your most novel feature? i.e. patentable is basically.
The most novel feature?
Yeah.
Yeah, so I would say it's the way that we're bringing these things together in a way that's different from before. So like, for example, that feeding arm that you set on a desk. So instead of requiring the desk to be in place, we're actually trying to make that part of the Sidekick unit while not allowing or preventing it from getting in the way of normal function. And then another example that I have is as far as like a charging unit for electronic devices. So for example, I've had my laptop nearly die with battery and I can't reach an outlet to charge it. So we're trying to provide that as part of the sidekick housing too. So it's really about letting the person go where they want without worrying about these other simple problems, so to speak.